Kia ora tātou. In this video we're going to be looking at pedigree charts. So pedigree charts are like family trees. So you'll see images that look a little bit like this, where you've got a square and a circle, and then the next generation will show various squares and circles as well. And so what this pedigree chart shows is that for each square, that generally represents a male, and each circle represents a female. And the shapes can be either shaded or not shaded, and the shaded will tell us, if a shape is shaded, then that tells us that that individual is affected by a particular or has a particular phenotype. So it might be that if we were to use our brown eyes, then we would say that every shape on this pedigree chart that is coloured in like that, that is shaded, has brown eyes. Brown eyes. And every shape that is not shaded would have blue eyes. So we can use these pedigree charts to then work out what the genotype of individuals could be. So I thought the best way to go through this would be to look at a past exam. So here we have a past exam from a couple of years ago. So photic sneezing is a condition which causes affected people to sneeze due to bright light. It can be traced through a family as shown in the pedigree chart. Photic sneezing, capital A, is dominant to unaffected, lowercase a. So let's have a look at these. So work out the genotypes of the following 4 individuals. So if you pause the video here, give it a go and see if you can work out these individuals' genotypes. So we're looking at number 1 first. So this genotype, we've got the phenotypes are either photic sneezing, or I'm just going to say not, to save a bit of time. So anybody who is unaffected, showing the unaffected phenotype, they can only have one potential genotype, and that would be lowercase a, lowercase a. Any individual that does have photic sneezing could be capital, I'm so used to B's now, capital A, or capital A, lowercase a. So here we've got individual 1, which does not show photic sneezing. It's unaffected, so there's only one genotype that that individual could be, and that's lowercase a, lowercase a. So that one needs to be lowercase a, lowercase a. If you weren't sure how to do this before, then you can pause the video at any stage to try and work ahead of me. So number 2 is, that could be either of these 2 genotypes. And the only way that we can find out is that if you think of our last video, where we were doing the pure breeding part of it, if this individual number 2 had capital A, that would mean that there would be a dominant allele passed on to every single one of their offspring. And that would mean that each of their offspring would be photic sneezers. But because we can see that some of their offspring, 3 out of 4 of them, are not photic sneezers, that must mean that this individual carries a recessive unaffected allele. So that must mean that because individual 2 has photic sneezing, it must carry a photic sneezing allele, and because the offspring from individual number 2 do not show, well, some of them don't show photic sneezing, it must also carry a non-photic sneezing allele. So let's look at individual number 11. So again, this is why pedigree charts are useful, because we need to look at the offspring of that individual. So individual number 11, if individual number 11 was homozygous dominant, then we would not be able to, that individual would not be able to have non-photic sneezing offspring. So for 11 and 12, these are going to be both the same. Because they show photic sneezing, they must both have at least one dominant allele. And because they were able to have an offspring that was non-photic sneezing, it means that they must both have a recessive allele there. So that's how to use pedigree charts. Questions come up quite often, so the best thing is to just do some practice. in your books or on past exams. There's a little bit more to it than what I've shown you, but just the main thing is to get the basics of it here. Excuse me, the basics of it here. Thanks very much for watching. Keep liking, subscribing for more genetic variation videos.